Let's do it. Corollaries of the mean value theorem. Corollary 1, we know that if f of x equals a constant, then f prime of x equals 0. That's how it already was. But by the mean value theorem, this is a two-way street, which means we can apply the if here and put the then there. If f prime of x equals 0 for all x, remember this means for all. If f prime of x equals 0 for all x in some interval I, then f of x is a constant over that interval. We'll prove it real quick. If f prime of x equals 0, it means f of x is differentiable because we have a derivative. And if it's differentiable, it's continuous. Remember doing this back in chapter 1? So we're going to do proof by contradiction. This is what this is called, proof by contradiction. I wanted to change the color here. Proof by contradiction. We are going to suppose that there is an f of x doesn't equal constant for all x, which means f of a does not equal f of b when a equals b for some points in the interval. Which means when we do the slope of those 2 points, f of b minus f of a over b minus a, that doesn't equal 0. But by the mean value theorem, f prime of c should equal 0, and we're saying it doesn't equal 0. I'm sorry, the mean value theorem is showing that the slope doesn't equal 0. This contradicts our assumption up here. Our assumption was f prime of x equals 0. That's how it is. But we just found an example where it did not have a slope of 0, which means that our supposed thing, f of x does not equal a constant, must have been false. Okay? That seems like a minor thing, but the next corollary is so fucking huge. If f of x and g of x are differentiable on I, and f prime of x equals g prime of x, then f of x equals g of x plus c for some constant c. And we're going to prove it using our last corollary. So we're going to let h of x equal f of x minus g of x, which means h prime of x equals f prime of x minus g prime of x, and that equals 0. Because g prime of x equals f prime of x, I could replace this with f prime of x right here. So I have f prime of x minus f prime of x equals 0. Bam, done. We get h prime of x equals 0 for all x in the I. By corollary 1, if the derivative is 0 for all x, it means that the original function had to equal some constant. H of x equals c for all x in that I. And if that's the case, then h of x, which equals f of x minus g of x, also equals that c. We add g of x to both sides, and we get what we're trying to prove. Okay? This corollary is super important. We're going to see it in chapter 5. It comes up later on in chapter 4, but it's huge in chapter 5. This is called family of curves, and you're going to see it's in chapter 5. Chapter 5, ends up being C is the constant of integration. This is going to be huge. It's an important rule. But we're not to integration yet. We'll get there. Another corollary for increasing and decreasing functions. F of x, we're going to say f of x is continuous on a closed interval AB and differentiable on an open interval AB. I don't know. I didn't like that I. If f prime of x is greater than 0 for all x in the AB, then we say f of x is increasing. And if f prime of x is less than 0 for all x, we say f of x is decreasing. The book has proofs on these. I don't think you guys are really excited about the proofs. If you want to see them, please look them up. A visual simulation of this. Wait, I want to make it even more look like it. Gosh darn it. I need an endpoint. Everywhere we look, the slope is increasing here. Sometimes it's not increasing a lot, but it's greater than 0 for all points. F prime of x is greater than 0 for all points. In between, this is my A and this is my B. We end up calling this an increasing function because it only goes up. It's up, up, up. And that's why we call it an increasing function. I kind of want to use that color. There we go. That matches the color I had for increasing. All right, we don't really have any exercises with that. We're just going to use that later on. But all of this stuff is stuff we use later on, but it's applicable here. That's it for the videos on 4.4. Peace out. I'll see you guys in class.